It's a great pleasure for me to introduce Mr. Philip Weathers, who is Director of Operations and Site Manager for Rentech Energy Technology Center, and also Managing Director of the Bioenergy Center of Excellence. Mr. Weathers is responsible for the overall operation of the Rentech Energy Technology Center in Commerce City, Colorado, which is located northeast of Denver. As site manager, he's responsible for the overall commissioning, startup, and operation of the Product Demonstration Unit, or PDU. He is also the overall site responsibility for commissioning and operation of the Integrated Biorefinery, a $35 million project integrating a RenTech Clear Fuels biomass gasifier with the PDU. The Integrated Biorefinery provides RenTech facility with a capability of producing up to 10 barrels per day of synthetic jet and diesel fuels from biomass-derived syngas using the Fischer-Tropsch process. Recently, Mr. Weathers was given the added responsibility as Managing Director of Rentech's Bioenergy Center of Excellence, which is created to leverage Rentech's investment in the Technology Center. Mr. Weathers is a part of a team of senior Rentech managers creating partnerships with private industry, government agencies, and universities. I highlighted that, university, yeah, to fully utilize a demonstration capability of the Center of Excellence. Prior to coming to Rentech, Mr. Weathers' career has included over 27 years with Eastman Kodak Company in a variety of engineering and management roles. His management assignments included Division Director of the Process Development Division, which focused on developing new technology for manufacturing photographic solutions used in Kodak's photographic film and paper operations. Mr. Weathers is also responsible for the production of Kodak medical image film at the Kodak Colorado division. During this assignment, he oversaw the implementation of a $60 million automated process for converting and packaging X-ray film. I really appreciate Mr. Weathers joining us today to talk about his particular facility. It's important for us to consider how we as researchers link up with what our research will ultimately produce in terms of products. I really appreciate your time because I know that you have a heavy schedule back home trying to get your unit online. With that, let's welcome Mr. Weathers.
Things when I worked for Eastman Kodak, I'd go to conferences and they'd have problems with the old carousel projectors and they'd ask if anyone knew how to use it, and I sat on my hands. I would not acknowledge. Usually got myself in trouble. Well, thank you, Ray. I appreciate being here today. What we're going to talk about a little bit is as you come through EPSCoR projects, you get through and into the pilot stage, what happens next? Most technologies can't jump from the research, pilot, bench scale into commercial. And what we have built in Commerce City, Colorado is a facility to allow us to take that next step. And we believe by generating the data in this facility, then give us enough information to go ahead and scale up to a commercial facility. Just a couple of comments on RenTech itself. RenTech's been around for 30 years. It was actually established, we had 4 founders, 2 of whom came out of the Solar Energy Research Institute in Golden, Colorado, now known as NREL. And they had a long history of taking what they were doing at NREL was actually biomass gasification. And they said there's something we ought to be able to do with the syngas. So they worked, they searched the literature, came up with the Fischer-Tropsch chemistry or Fischer-Tropsch reaction, and began to develop a catalyst that was a proprietary catalyst that would then allow them to make synthetic fuels from out of the syngas that they were producing. We have locations with, our headquarters is now in Los Angeles, Colorado. We were actually founded in Colorado, or in California, founded in Colorado. We have all of our technology development facilities in Commerce City. We own a site in Natchez, Mississippi, which we are looking in the future to develop. Clear Fuels, as we acquired that technology, is in Honolulu. Everyone wants the assignment there. And then East Dubuque, Illinois is the site of our ammonia plant, and I'll talk a minute about it just in a moment. But we've got, between the experience with the original Rentech and with the ammonia plant, 30 years of operating experience and 40 years of experience in producing syngas. Most of that history was producing syngas from natural gas. That's where the nitrogen started, and quite honestly, that's where we started at the facility that you're going to see here in Commerce City. And then started really building that facility in late 2006, early 2007. We came on stream in 2008. We've been producing syngas and drop-in fuels at the site since August of 2008. And as Ray alluded to a moment ago, we're in the process of starting up, and we'll spend most of the time talking about our biomass gasifier that we will then go from getting the syngas. Instead of from the natural gas source, we will begin using various forms of biomass. And we're going to talk a little bit more about the gasification technologies. Last year, Rentech did an interesting thing. Whereas we were all sort of one company, one trading source, we actually formed a master limited partnership with the site in East Dubuque, Illinois, and that's a picture of it. It sits on the bluffs of the Mississippi River. Spun that off and sold 40% under the stock trading symbol of RNF, and Rentech remains the majority owner of 60% of the stock for that company. It now has a market capitalization of close to $1 billion and produces about 600,000 tons of ammonia per year. And we are in the process now of putting together an expansion project. It was a fortunate turn. We actually bought that with the intent in 2007 of converting it from natural gas to coal, because natural gas price was high. The ammonia price was low. We were trying to make it economic, and we were going to put a Fischer-Tropsch reactor at that site. Some funny things happened as we were trying to get there. The coal became something that was going to be very difficult to permit. I think we could have gotten it permitted in the state of Illinois, but probably would have gone through many years of legal challenges to doing coal gasification because there was not a good CO2 solution at that site. And secondly, with the takeoff of ethanol, the price of ammonia and fertilizer products went up, and this has been the cash cow that has driven our R&D since 2007. So it's turned out to be very fortuitous. We are one of the few companies that are in this biofuel space that have actually had a source of income coming from another part of its business to help fund the technology. We're going to spend most of our time talking about this site, which is it's known both as the Rentech Energy Technology Center, and now within that, as we are bringing up the biomass gasifier, the Bioenergy Center of Excellence. In terms of our technologies, we really own three. I'm going to start over here. This is the Fischer-Tropsch process, where we take syngas from pretty much any source, clean it, adjust it to the right ratio, put it through our reactor, and that is the Fischer-Tropsch reactor at the Bioenergy Center of Excellence. It's 110 feet tall. It's about 16, 18 inches in diameter. And if you were to look, it produces around 10 barrels a day of Fischer-Tropsch liquids. 7 of it would be either drop-in diesel or drop-in jet fuel. And the balance is naphtha, which is a lower BTU product. And we really haven't been trying to deal with it as to what we're going to do. We've been able to sell it to a jobber that has need for those types of materials. But we've been very successful. In fact, we're well right now. We normally run 30 to 60 days campaigns, and the current one has been on stream for well over 100 days now, with very good performance, very good stability, and continuing to produce the Fischer-Tropsch liquids. A couple years ago, we bought a technology known as Silvagas, biomass gasifier. It actually had a 400 ton per day unit in Burlington, Vermont, connected to their power station there, which was wood burning. It was part of also a DOE grant at that time. That was before we owned them, and demonstrated the technology. It's a dual circulating fluidized bed. I'll have a little bit different picture of it here in a moment. But it was really done with wood. They did not use any of the other energy crops at that point. We believe that it has been proven and is ready for commercialization, and right now we're talking a number of projects where we might use the Silvagas versus the other gasification technology of clear fuels. It's probably better suited for one where we're emphasizing the production of power, whereas clear fuels is better suited for if we're going to produce hydrogen or fuels, although both can do either technology. It's just the balance that you get out of the two technologies. We've proven this one at pilot scale, the clear fuels. Was actually done in Aberdeen, Mississippi, and we are now in the process of bringing it up in Commerce City to take it to the demo scale there. This has been proven at commercial scale, and we have proven at demonstration scale our synthetic Fischer-Tropsch process. They are drop-in fuels. This is our CEO, Hunt Ramsbottom. We actually participated with Green Car Congress magazine and Audi, and drove a car down the coast of California a number of months ago. We ended up buying the car, and have been, we've driven it from California to DC Auto Show and back, all on fuel produced there at the site in Commerce City. That's about the only thing it used, and it is the only thing that we've used. It was quite a challenge chasing that car across the country with 5-gallon cans of diesel, but we managed to do it. And it's got about 60,000 miles on it at the moment, and running great. This is the United plane. I believe that's Bob Sturtz, who is the chief fuel buyer for United. We took fuel from the site, jet fuel. Jet fuel is only certified at a 50-50 up to a 50-50 blend. We blended it with normal commercial fuel, and they flew it out over Kansas and back with our CEO and chairman of the board on it. Our chief technology officer got to go because they went, he was going, just to make sure. All reports and the data that came from it it was an excellent performance. In fact, they landed it, there was still some of the fuel left in the tank, they refueled and took off on a commercial flight with the same plane after they were done. And then that was just kind of one of our gee whiz experiments with conventional diesel and Ren diesel, and again, the particulate matter coming out, you can kind of see the difference between the two fuels, because the Ren diesel is an extremely clear form of fuel. So let's focus a little bit on the Bioenergy Center of Excellence. We actually, as I mentioned, produced our first fuel in August of 2008. We've done it under the name the Rentech Energy Technology Center, because what we're doing there is using a steam methane reformer to take natural gas and convert it to syngas. Now with the advent of the biomass gasifier and our focus on bioprocessing, we have formed within the organization, or at the site, the Bioenergy Center of Excellence. So again, the two different names, but both the same location, and essentially the same group of people working in the area. It really is a site which we have designed to be highly flexible. We could bring in other technologies, and we are talking with other companies about partnerships where they may need our bioproduced hydrogen, they may want our bioproduced syngas, or they may want to take their process and just upgrade it to either using our upgrading technology to different types of fuels. We can also use wax, which is the intermediate produced in the Fischer-Tropsch. It's referred to as wax. It's a paraffinic material at room temperature. It is, I mean, smells like, tastes like, looks like wax. Any paraffin wax that you see, except it's a little bit harder. That's, if you hear me use the term wax, that's what I'm talking about. Our fuels do meet the specs of the ASTM specs for diesel and the specs for jet fuel. We have been focusing on natural gas. We are beginning to bring up this, and we've probably run now close to 100 hours total. And I'll talk about some of the issues we face as we've brought up the biomass, but all on different types of wood material. We've used pellets from the pine beetle kill there in Colorado. There's some companies that have been pelletizing it. We've used it, used some microchips of southern white pine out of Alabama. And then we're using our normal, what's kind of referred to as hogwood. It is a recycle site there in Colorado that gathers tree trimmings and everything, runs them through a chopper to about 3 inches minus, and then sends them to us for grinding and use that. And actually, that's the one we'll be trying tomorrow morning as we go through another test. All told, we've got about $150 million invested in the center here. We have 70 scientists, engineers, technicians, and operators. About half are in that technician scientist range. The other half are in the operator and environmental health and safety. We've got 3 catalyst development labs because as we continue to develop the Fischer-Tropsch catalyst, we're refining the recipe. And we've got an excellent analytical lab that is focused on fuels testing as well as testing of many of the intermediates such as the wax, looking at the effectiveness of our wax catalyst separation technology, things of that nature. So we're very well equipped in this analytical lab. And then we have another lab that allows us to look at this essentially liquid-solid separation, but do it at room temperature. We're using oils of densities and viscosities that match what the wax would be in the reactor. And we're able then to do things at room temperature in plexiglass-built equipment. And that's part of the laboratory as well. So with the addition of the Clear Fuels gasifier, and I'll show you kind of the differences between that and the Silva gas in a moment, we've created this Bioenergy Center of Excellence. We've used $23 million that was awarded to Clear Fuels from the DOE, and we've added to it $13 million of investment from RenTech shareholders. It's going to allow a flexibility. We, as part of the completing the DOE trial, will be using wood and sugarcane bagasse. Again, Clear Fuels was founded in Hawaii and kind of has its roots there, and that was one of the original proposals, was to show that we could use the waste from the sugarcane mill to make diesel primarily. And we have all of the necessary equipment also to take any syngas that's produced, separate out the carbon dioxide as well as any other impurities that might come from the particular syngas source or feedstock source. That'll be the one that we'll probably be putting more to the test here in coming days. Natural gas is a breeze to clean up. Now as we begin to bring in the wood and the switchgrass and the bagasse, things of that nature, we'll have other components that we're going to need to get out of the system. That is the shell of the reformer as it was being set into place just a few months ago. We actually broke ground in June of 2011. We did a mechanical completion in November of 2011, commissioned the equipment, and are now going through some of the growth pains that you go through as you try to bring up any good size process. But the good news is the core technology in here has been performing as expected. It's been some of the linking equipment that's been more of the issue. What we do at the Bioenergy Center of Excellence is we spend a lot of our time trying to get what through is kind of called the valley of death for many technologies, getting out of 6 into 7 from a technology readiness level. We believe we've gotten with our natural gas, we've gotten natural gas to fuels at a TRL of 7. Although we have not demonstrated it at this site, with the demonstration in Burlington, Vermont, we believe we can do biomass to power with a readiness level of 7. And we think we're around 6 and working towards 7 as we're bringing up the biomass gasifier. We do work down in the earlier stages. I haven't listed because it's not ready for prime time yet. But we do some of our own work in this area. We also are looking at companies that want to come in and maybe are in this area and want to move on up and can use, as I mentioned earlier, the syngas or the hydrogen or the upgrading capability. And as we develop those relationships, then we will bring those on board as well. These are kind of the technologies. I will qualify. Ag waste is really things like corn stover. We haven't gone into any of the types of liquid waste or things of that nature that some people might be looking at. We certainly can do natural gas. At one point, we were looking at putting a gasifier that could do coal and petcoke, but with the change in emphasis away from coal, as well as with some technical problems that we were encountering, we walked away from that and went to the natural gas instead. So we integrate the gasification and processing technologies. We utilize the Fischer-Tropsch chemistry, which is quite old chemistry, and we're developing the iron-based catalyst. I'm going to skip through these. I'm coming close. Ray gave me the high sign. But really the two different technologies, one is a dual fluidized bed, and this is a more traditional reforming of biomass. It's non-catalytic. The actual manufacturer of that reactor that I showed setting in place is the same company that made the steam methane reformer that we have on site. And so we've got a lot of experience and now trying to bring it up. Our Fischer-Tropsch technology is three-phase, bubble column, syngas in, catalyst inside. You form the paraffin material that becomes the liquid phase. We bring it out over top and we take the catalyst out, or we take a clarified wax off, put the rest of it back in, and we have that type of circulating reactor as we produce more and more of the paraffins. We go from there into a upgrading based on UOP, which is a Honeywell company. It's kind of the premier hydroprocessing technology company in the US. We've got hydrocracking, hydrocracking for the more waxy products, hydrotreating for the lighter products, and we use that equipment then to produce the diesel and jet fuel. Won't go through this. This was an eye test, really, but it kind of shows you the complexity as we flow through the biomass. Here's the feed handling, here's the gasifier, here's the initial gas stream cleanup as we're going through cyclones and a Venturi scrubber. We come through different stages of gas stream cleanup using different contacting wash techniques, and then we come into the Fischer-Tropsch and product upgrading area. Many different units that are linked together in order to get down in here where we are actually producing the jet and diesel. I've pretty much covered all of that. Let me give you just a quick photo tour. This is the entrance to the site. That's our reactor. The rocket-looking thing is our flare. This is the steam methane reformer. That is the biomass reformer, and this is all the feed handling equipment that goes along with that biomass reformer. This actually is where we dock the truck. The next photo will show the truck. We use walking bed trucks because we are a small operation. Come in with the feed, dock here. There's the truck docked. Goes down underground, comes up in a moving belt conveyor, goes through a weigh belt, some magnetic detection to get any metal that might be in there out, and comes through a conventional knife rotary grinder, a Jordan grinder at this point. Comes out of there, goes through a vibrating belt dryer, under the road, up to the top of this structure, where it is a 2-hour capacity feed hopper, comes through a rotary valve to control the feed, goes through a steam mixing vessel to integrate the superheated steam and the biomass, and up and into this reactor, which has a helical coil, 2 helical coils inside. And that's where the reaction takes place to create the syngas. Out of there, we go through to waste heat recovery, as well as Venturi to do some scrubbing, and then we actually link up with the rest of our process. When the biomass syngas is flowing, there's a syngas compressor right now that takes the syngas from the reformer, steam methane reformer. This will be shut off, and we will connect the biomass and come through the Fischer-Tropsch, the upgrading area, after we go through the gas stream cleanup. We'll use this as status challenges questions. We are in the process of starting up. Most of the problems and issues we've faced have been in material handling. We discovered we're a process chemical process organization used to handling liquids and gases. We had a little more difficulty dealing with some of the material handling, both the conveyance as well as feeding out of that feed hopper. We've resolved that problem, and so we got through the syngas reformer, and then discovered that we had some issues with our gas stream, with the heat removal system. There's kind of what was designed and put in there was a very traditional gas waste heat boiler. And unfortunately, our gas has a combination of syngas plus char plus ash plus tars, and it's not the right design. And we're going to make this run tomorrow. We'll come down for about a week, and we're actually going to bypass that boiler and go to a different way of cooling the syngas, and then come back up. So that's kind of our status. We're looking forward to get it there. We have a commitment to the DOE of a 2,000-hour run. That's about 3 months. We will be using the different types of wood as well as the sugarcane bagasse. We've got one trailer load sitting there in a chilled trailer from Hawaii that got shipped over. The rest of it we'll bring up from Louisiana area where there is some bagasse sources. So I'll stop there, and anyone have any questions? For our process industry, especially in the operator area, we're relying primarily on folks that, for instance, like we have a Suncor refinery right across the creek from us. We're limited in Colorado for that type of resources. We've actually brought some contract folks in from the Gulf Coast. In fact, a number of them from either Oklahoma or Texas that we've had working with us all along. That is a challenge for us in the location where we are. It may well be a challenge depending upon where you're going to put one of these refineries. If we put it in the source of biomass, it's not necessarily going to be in the same Gulf Coast region where you find a lot of petroleum workers. So that's an area. There are a few programs out there that we've hired out of. One at North Dakota. It's Bismarck State in Bismarck, North Dakota. That Dakota Gasification helped build that program over the years, and they're now actually up to a 4-year program. Operators we've gotten from there are very well trained. Others, it's been a lot of on-the-job type of training. Those are the primary types of folks we focused. Our technicians, we've got a reasonable pool of people with technician skills, analytical skills. I think as we get out into the commercial range, though, all of that's going to be more difficult to find. And as we've worked on some of these grants, like some of the USDA grants that talked about education and outreach, one of the commitments we would make is we would actually bring students, whether they be out of the university or even perhaps students in the latter part of high school, to the site and let them shadow operators, find out what that type of education or workforce is really like. Larry?
Any activities with municipal solid waste?
We've talked about it, and that's probably as far. We've had a couple of conversations. One of the original Clear Fuels founders has been doing some work with the company. You've got to go through a pre-processing step. Municipal people think of municipal solid waste as you just bring in the truck, dump it, grind it, and put it in. And maybe if you were operating with plasma gasifiers, that would work. But in this type of gasification, we're going to have to separate out, find the carbon-containing material, and it's going to have to be put into some type of pellet or particle form for us to handle it. So the conversations are underway. How fast we get there, I'm not sure.
One last question. Up there. Brad.
What are your waste? What's your waste stream? What's the residual during processing?
Um,
What's the plan for it? Where does it go?
Well, the waste streams, a number in the biomass area. We've got ash. It's non-toxic with the materials that we're using. and it will go actually into a dumpster and be hauled off by Waste Management. One of the things we have to do right now is separate out some of the tars. Those come into a wastewater. They're going into a tank, and we will be installing here a waste treatment facility. It's been designed by Siemens later this spring. And we will actually treat the water to the point that it can go into the municipal system, into the POTW.
Is that a biologically based treatment, or is it biological treatment?
You know, I'm not sure. I haven't followed I haven't really followed the technology. I mean, there's a number of steps to it. I think there are some enzymes involved in there, so there are some bugs, and then there are a number of beds of carbon, things of that nature to filter it. But they believe they can take it there. And then our wax and catalyst, which sometimes, depending upon the catalyst in Fischer-Tropsch, is non-toxic. We literally, when we go from one run to another, we'll drain that reactor with the wax catalyst in it, put it in a roll-off, let it harden, and again, Waste Management takes it as a non-toxic waste to their landfill.
We need to move on. Phil's going to be here through maybe mid-lunch.
Yep.